Earth's magnetic field just flipped, and nobody noticed. The Earth's magnetic field is changing in ways that we couldn't have predicted. But what does it mean for us? Will our electronics start to malfunction? Will animals get confused? Will deadly solar radiation suddenly start frying our brains? Let us take a look at what just happened with the Earth's magnetic field and whether we should be worried about it. And while scientists were expecting something like this to happen sometime between now and 2060, nobody was prepared for it to occur quite so soon. The Earth's magnetic field is always shifting around and changing. And according to researchers at the British Geological Survey, that's exactly what happened on March 9th. The Earth's magnetic field is constantly being buffeted by the solar wind, a stream of charged particles flowing out from the sun. As the magnetic field lines move and change, the way that those solar winds interact with them changes too. The Earth's magnetic field is generated deep within the planet's core, specifically in the outer core. This part of the core is a layer of liquid iron and nickel, about 2,000 kilometers below our feet, that's churning around thanks to heat from deep within the Earth. Scientists have been paying close attention to our planet's magnetic field since the early 1960s. Back then, they discovered that the Earth's magnetic field was weakening, meaning the magnetic protection that shields us from harmful cosmic radiation was getting weaker. And that raises the question, should we be worried about it? Since then, this trend has continued, and it appears to be accelerating. Studying tree rings going back thousands of years, scientists can measure the amount of carbon-14 atoms present in each ring. But when the magnetic field weakens, more and more cosmic rays reach the surface, leading to more carbon-14 being created and incorporated into living tissue. When scientists looked at the ratio of carbon-14 atoms in tree rings dating back to 780,820 CE, they saw a spike indicating a big increase in cosmic radiation around that time, which means the magnetic pole flip back then was pretty intense. Carbon-14 dating is based on the fact that cosmic rays constantly bombard the Earth with their radiation, some of which hits our atmosphere and reacts with nitrogen to form carbon-14. See, it's not just the magnetic field that's changing. The Earth's axis of rotation is also shifting. If we pay attention and prepare ourselves, it won't be a problem. Well, maybe a minor inconvenience, but not a disaster. It also causes changes in the length of a day, which could mess with our infrastructure that relies on precise timekeeping. We've made thousands of educational videos over the years, and we've been able to offer them for free because of our patrons. So to all of our patrons, thank you for what you do to make this happen. If you're not a patron, but you want to learn more about what that means, you can go to our support page. And if these changes are happening faster than usual, it could potentially throw off migrating birds, disrupt important ecosystems, and lead to widespread blackouts and global chaos. For example, understanding how ocean currents will change will help us predict how weather patterns will change, allowing us to prepare accordingly. Understanding how the length of a day will change will allow us to adjust our clocks ahead of time instead of waiting for the disruption to happen. Between 1981 and 2020, the Earth's axis moved from near the geographic North Pole to near the Greenwich Meridian, a distance of about 110 kilometers. Carbon-14 atoms then get incorporated into the tissue of plants during photosynthesis and eventually make their way into animals that eat those plants. Once an organism dies, however, it stops taking in carbon-14. But scientists aren't sitting around twiddling their thumbs. They're working on a number of different ways that we can prepare for the inevitable. Changes to the Earth's magnetic field and axis of rotation will affect different parts of the globe in different ways. So scientists are working to model these changes and understand how they'll impact local environments and infrastructure. So scientists can use the amount of carbon-14 atoms remaining in a sample to figure out how long ago that organism died. They've happened many times throughout Earth's history and will continue to happen in the future. In fact, it's not even the first one that we've seen in modern history. A geomagnetic reversal occurred back in 788-20 CE, when the Earth's magnetic field flipped, and the magnetic poles switched places. As the liquid metal churns, it drags the magnetic field lines along with it, creating the magnetic field that we all know and love. This weakening is thought to be linked to the movement of our planet's magnetic poles. Both magnetic poles have been drifting away from the geographic poles for decades. And as they move, the magnetic field lines become stretched and thinner, leading to a weaker overall magnetic field. But what causes this churning motion in the first place? Well, it's not entirely clear. And by measuring those interactions, scientists can track the strength and direction of the Earth's magnetic field. Hotter, less dense material rises toward the top, while cooler, denser material sinks toward the bottom. But exactly how this works and what else might be contributing to the churning motion is unwell understood. So it's hard to say why the magnetic poles would suddenly flip. They were monitoring seismic activity in the Earth's core and noticed a sudden and unexpected change in the magnetic field signals coming up from inside our planet. There are also observatories on the ground that are continuously recording the direction of the magnetic field. And scientists can even use certain types of headphones to listen to the changing magnetic field by placing them on the ground, where they pick up telluric currents, electromagnetic signals generated in the Earth's crust by changes in the magnetic field. All of these methods revealed the same thing. On March 9th, the Earth's magnetic field did a flip. That abrupt change is what indicates a magnetic pole flip has occurred. Magnetic North, for example, currently sits in northwest Canada and has been slowly drifting towards Siberia over the last few decades. It may be moving faster than ever before, but it's still moving at only a few centimeters per year. In case you didn't know, the Earth has a giant magnetic field. It acts like an invisible shield, protecting us from harmful cosmic rays. This magnetic field extends thousands of kilometers out into space and is generated by the motion of our planet's molten metal core. It also happens to have a North Pole and a South Pole, which are not exactly at the geographic North and South Poles, but close enough that it isn't confusing. And it's generally accepted that these magnetic poles are what compasses are actually aligning themselves with when they point north. Now, believe it or not, this magnetic field actually flipped a few days ago, meaning that Earth's magnetic North Pole became its South Pole and vice versa. The thing is, though, while a magnetic pole flip might sound dramatic, it's actually more of a gradual process. What makes a magnetic pole flip, then, different from normal drift? It's when the magnetic field lines abruptly change direction. But how do scientists even know that a magnetic pole flip happened? Because we can measure these things. For example, there are satellites specifically designed to measure the strength of the magnetic field, such as the European Space Agency's SWARM satellites. But why this happened is a bit of a mystery. Scientists think it's probably due to convection currents within the liquid iron and nickel, kind of like boiling water. However, it's likely related to other changes that have been happening in the Earth's core. One study published in 2022 found that the magnetic field had weakened by almost 9% between 1960 and 2020. It seems likely that the recent pole flip is just the latest event in a string of increasingly drastic changes to our planet's magnetic field. Well, the short answer is no, not really. Magnetic pole flips are nothing new. And we can even tell that this reversal wasn't particularly gentle. When the Earth's magnetic field is strong, those cosmic rays are kept away from the surface of the Earth. But while past magnetic pole flips haven't seemed to cause any major problems, our current flip might be a little more chaotic. That change has a number of effects. For example, it alters ocean currents, which affects weather patterns and sea levels. But really, we don't know exactly what will happen until it does happen. And once they have a better idea of what might happen, they can work out what we need to do to mitigate any negative effects. So while a magnetic pole flip might sound scary, it's really just another step in the never-ending cycle of change that our planet goes through. Thanks for watching this episode.